The next type of function we're going to talk about is absolute value function. So an absolute value function is actually a piecewise function. It's made up of two pieces of a graph. The absolute value is always non-negative. The parent function will only include non-negative values. So when we look at the parent function of an absolute value, it's just the absolute value of x. Okay, and if we look at the graph, it's going to be negative numbers and positive numbers, and there's 0 as a value. So the type of graph is always going to make a V shape. I like to think of absolute value as a V, so it forms a V. The V could be upside down as well, but it's going to have that V shape. The domain is going to be all real numbers, and the range for the parent function is all non-negative real numbers. The range is going to be either y is greater than or equal to, or y is less than or equal to some value, depending on where the vertex of the point is. So if we look at an example, graph the value f of x is x, my absolute value of x minus 4. So if we put some values in for x, the way we're going to determine which values to put in for x, we're going to take x minus 4 and set it equal to 0. Okay? And then we're going to solve. So x equals 4. That is going to be the middle. That's where the vertex is going to be. So that we're going to set as the middle of our graph. So x is 4. And then we're going to take numbers less than and numbers greater than. And then we're going to plug these in. 1 minus 4 is negative 3. The absolute value would be 3. 2 minus 4 is negative 2. The absolute value is 2. 3 minus 4 is negative 1. The absolute value is 1. 4 minus 4 is 0. The absolute value is 0. 5 minus 4 is 1. The absolute value would be 1. 6 minus 4 is 2. And 7 minus 4 would be 3. What you should notice, if you solve take what's inside and set it equal to 0, and you start at that point, the points below and above should be a mirror image. You see the symmetry here. Okay, that means you did it correctly. So now we're going to graph these points: positive 1, positive 3, positive 2, positive 2, 3, 1, 4, 0, 5, 1, and then we're kind of off the graph, but we'd have 6 and 7, and then if we connect those with a line, they're linear. You see that V-shaped form. Okay, the domain is going to be all real. Okay, so we can write that as x, such that x is the element in the set of all real, and the range f of x, such that f of x is, if you look at this, the lowest point it is 0, so greater than or equal to 0. And this implies that it's going to be all real numbers greater than or equal to 0. So that's how you figure that out. Okay.